Today we are going to learn how to solve a new type of equation. We are going to solve absolute value equations. But first we need to remember what the definition of absolute value is. What do you remember about the definition of the absolute value of a number? Absolute value is a number's distance from zero. It is how many spaces the number is from zero on the number line. So my first equation is the absolute value of x equals 2. Well, if something has an absolute value of 2, what can it be? Well, 2 has an absolute value of 2, right? And negative 2 has an absolute value of 2. So x can be 2 or x can be negative 2. So we can leave our answer like that, x equals 2 or x equals negative 2. We could, since it's the same number with different signs, we could say x is plus or minus 2. Now, let's look at the next one. It says that the absolute value of 5z is 40. So the absolute value of something is 40. What kind of numbers have an absolute value of 40? Well, 40 has an absolute value of 40, right? And negative 40 has an absolute value of 40. So this 5z, it can equal 40 and have an absolute value of 40, or 5z can be negative 40 and have an absolute value of 40. So we've created two equations here to solve. They're going to be very simple equations to solve. These are just one step. We're going to divide both sides by 5. So z is 8, or divide both sides over here. Z is negative 8. So for this problem, z can be 8 or z can be negative 8. We have two solutions. The next one says the absolute value of w minus 3 equals 4. What two numbers have an absolute value of 4? 4 has an absolute value of 4, and negative 4 has an absolute value of 4, right? So w minus 3 can equal 4, or w minus 3 can equal negative 4. So we're going to solve both of these. We're going to add 3 to both sides. These are just one-step equations. So w can equal 7. And over here, when I add 3 to both sides, I get w equals negative 1. So these two solutions are 7 or negative 1. And notice, and we won't do this every time, but notice if I plug 7 in, 7 minus 3 is 4, and the absolute value of 4 is 4. Or if I plug negative 1 in, negative 1 minus 3 is negative 4, and the absolute value of negative 4 is 4. So both of these numbers make the equation true. Okay, now I have that the absolute value of 2v minus 5 equals 17. Well, what two numbers have an absolute value of 17? 17 has an absolute value of 17, and negative 17 has an absolute value of 17, right? So we're going to take what's inside the absolute value. I get negative 2v minus 5 equals negative 17, or negative 2v minus 5 equals negative 17. So I have two equations to solve. I want to point out here, notice I didn't change any of the signs inside the absolute value. Negative 2v minus 5 stayed negative 2v minus 5. But I took this number over here and I set it equal to the positive and the negative of that. And I just see that I messed that up. That should be 17 or negative 17. Okay, so you solve negative 2v minus 5 equals 17 and solve negative 2v minus 5 equals negative 17 and tell me what your two values of v can be. I got v equals negative 11 or v equals 6. So my two solutions are negative 11 and 6. Absolute value equations most often have two solutions. Well, sometimes there is extra stuff outside the absolute value bars. And when that happens, you want to isolate the absolute value. You've got to get the absolute value by itself before you can do anything else. So this first equation here, I have the absolute value of y minus 8 equals negative 5. So this minus 8 is over here with the absolute value. I need to get the absolute value by itself. So I'm going to add 8 to both sides, and I get the absolute value of y equals negative 5 plus 8 is 3. After you get the absolute value isolated, then you want to write your two equations, right? What two numbers have an absolute value of 3? 3 has an absolute value of 3, and negative 3 has an absolute value of 3. So I'm going to say y equals 3 or y equals negative 3. Now, in this case, there's nothing to solve, but at this point, this is where you would solve each equation. So that one, we had to add the 8 to both sides. On this next one, I have negative 2 times the absolute value of z plus 3 equals negative 14. So here's my absolute value, and I've got to get rid of this negative 2. Well, this is negative 2 times the absolute value of z plus 3, so I'm going to divide both sides by negative 2. Then I get the absolute value of z plus 3 equals, that should be 7. Now I'm ready to write my two equations, right? What two numbers have an absolute value of 7? 7 and negative 7. So this is where I'm going to write two equations. I'm going to say that z plus 3 can be 7 or z plus 3 can be negative 7. Now we're going to solve each equation. You solve them. Tell me what your two solutions are. My two solutions are 4 or negative 10. If I plug either one of those back into the equation, they will make the equation true. Here's a type of equation we haven't seen in a while. Notice I have my absolute value of 2w minus 4, and it's all over 6, right? So when we had something that was all over a number, we have to get rid of that first. So this is all divided by 6. So the first thing I have to do in this equation is multiply both sides by 6. So these 6's cancel. I'm left with the absolute value of 2w minus 4 equals 18. Once the absolute value is isolated, then you write your two equations. What two numbers have an absolute value of 18? Negative 18 has an absolute value of 18, and positive 18. So you take the stuff that's inside the absolute value, you do not change it, and you set it equal to negative 18, and then you set it equal to positive 18. Now you're ready to solve these two-step equations. So solve these two two-step equations and tell me the solutions to this absolute value equation. The two solutions to this absolute value equation are negative 7 or 11. So this next one has a couple of things going on around the absolute value. It says 7 times the absolute value of 4n plus 8 minus 6 equals 106. Remember that our goal is to isolate the absolute value. So look at this and tell me what you think we're going to do first. So I have this minus 6, and I have this 7 times this. Think about this as a two-step equation. This is sort of like 7x minus 6 equals 106, sort of, kind of. So we need to take care of the minus 6 first. So we're going to add 6 to both sides, and we get 7 times the absolute value of 4n plus 8 equals 112. Then we're going to divide both sides by 7, and we get the absolute value of 4n plus 8 equals 112 divided by 7 is 16. Now that the absolute value is isolated, we are ready to split it up. What two numbers have an absolute value of 16? Negative 16 has an absolute value of 16, and positive 16 has an absolute value of 16. So our two equations are 4n plus 8 equals 16, or 4n plus 8 equals negative 16. Remember, we don't change anything of that expression that is inside the absolute value bars. Okay, you have two-step equations. Solve them. Tell me what the solutions to this equation are. Our two solutions are 2 or negative 6. As with a lot of things in math, sometimes there are special cases. Here is the special case for absolute value. Let's say we want to know the absolute value of what number is negative 6. Well, what do you know about absolute value? Absolute value is never negative, right? Because it's distance. There is no number whose distance from 0 is negative 6. You would never say that you walk negative 6 spaces from somewhere, or that there are negative 6 spaces from 0. So there's nothing that has an absolute value of negative 6. So you're going to like this because there's no answer. The answer is no solution. There's nothing to work. Okay, so this one we see negative 3 times the absolute value of 2x plus 1 equals 21. Well, that's multiplication. I see this 21 over here. So far, I'm good. But I need to divide both sides by negative 3 to isolate that absolute value. And I get the absolute value of 2x plus 1 equals negative 7. Well, what has an absolute value of negative 7? Nothing. So since nothing has an absolute value of negative 7, how do we answer this problem? We say no solution.